All right, let's look at this conditional. If the product of two numbers is even, then both numbers are even. We want to prove this statement using indirect reasoning. Indirect reasoning is like that backwards kind of reasoning, where we want to show something is true, so instead we assume that we are wrong, right? So we want to show that if the product of two numbers is even, then this is really the conclusion here, that the numbers are even. So if I want to start it indirectly, I'm going to assume the opposite of the conclusion. And since my conclusion is that they are both even, the opposite of that is that both numbers are not even. That would be part B. All right, number 8. I told you to skip number 6 and 7. Vertical angles are fantastic. They're not on your test tomorrow, so don't worry about them. So that's why we're moving on to number 8. Okay, we have all these premises below. P gives us R, S gives us not R, and we have P. These are all given statements. We want to know, does the conclusion S follow from these premises? All right, well, let's look at them individually. Okay. I'm just going to select 2 of them. And the reason I'm going to select these 2 specifically is because I already know a law of logic that allows me to combine the 2 of them. If I take the premise P arrow R and P, I can get back the result R by the law of modus ponens. Right? That gives me that conclusion. All right, that's great. You might be asking yourself, why do we need that? Well, let me just take this now, our other conclusion, and R, which I got using a logical law. So it's okay for me to use it. It's more information that we know is valid. I'm going to take my S arrow not R and the statement R and see, is there a law of logic that allows me to combine these 2? And there is. I have if S then not R, but R does happen. It's the opposite of that conclusion, which allows me to conclude that not S happens based on modus tollens. So does the conclusion S follow? No, the conclusion does not follow. Not S is the conclusion of this information here. Now, are you going to be tested specifically on this? No, you're not going to be tested on it. However, we are going to give you 2 statements and ask you what is the conclusion? Or I may give you a statement and a conclusion and ask you, what was the other premise that allowed us to get that conclusion? Okay? And most likely we're going to do this in words. All right, below. Last one, number 9. We want to know, are the 2 statements logically equivalent? We have to look, in order to determine logical equivalence, we have to know, is the last column in their truth tables the same? That's what we're really asking you. And if the answer to that is yes, then they're logically equivalent. If the answer is no, then they are not logically equivalent. Okay, so in order to do this, I need to write a truth table. So I'm going to do that here. We've got P, Q, and if we asked you to do this on the test, I would give you the truth table already filled out, so don't worry about that. I'm going to need not P. I'm going to need not Q. I'm going to need to know P or Q. I'm going to need to know the opposite of that statement. And I'm going to need to know not P and not Q. These are all things I'm going to need to look at the truth values for these 2 statements. All right, these first 2 columns are given to you. The opposite of the P column is false, false, true, true. The opposite of the Q column is false, true, false, true. The statement P or Q, I'm looking here, P, and I'm looking here at Q. True or true is true. True or false is true. False or true is true. False or false is false. That's because the rule for the or was false or false equals false. That's what I was looking for. All right. For this one, I just actually have to take the opposite of these values I just got here. So the opposite of true is false. The opposite of true is false. Opposite of true is false. Opposite of false is true. All right. Last column. I want not P and not Q. So basically, I want this column. Oop, not what I want to do. I want this column and this column. The rule I'm looking for here is true and true equals true. So let me look here. I don't have true and true. No. No. Yes, right there. So that one is true. And the rest of them are all false. All right. So finally, we come down to the question, are these logically equivalent? And in order to determine that, let's look at their columns. These are all the values for this first statement, and these are all the values for the second statement. They are identical in every single row. Because the last columns are the same, yes, they are logically equivalent. And by last columns, I mean really the columns that represent all of their values. Logically equivalent because truth values are identical. All right.